What is C++? Why we use C++? How to learn C++ as a beginner. Can I learn C++ when I have zero knowledge? So, let's start learning C++ together and unlock the world of programming. What is C++ used for? C++ is popular because it's fast, reliable, and versatile. It's widely used in many areas, such as operating systems. C++ is used in Windows, Mac OS, and iOS, graphical user interfaces or GUI. It helps in designing interactive software screens. Virtual reality or VR. C++ is a great choice for building immersive VR experiences. Game development. Famous games like World of Warcraft and gaming consoles like Xbox use C++. Software applications. Apps you use every day, like Netflix and Amazon, are built with C++. This is why C++ is one of the most powerful and widely used programming languages in the world. Why we use C++. It is a general-purpose programming language used to build software of all kinds. What makes C++ powerful is that it is object-oriented. This means, instead of focusing only on functions, it focuses on objects, where data and related features are grouped together. For example, think about a user account on a website. It contains a name, an email, and a password. All these details can be treated as one object, making it easier to manage and reuse. That's the basic idea of what C++ is. The power of C++ is its unparalleled control. This journey is complete, teaching you how computers truly work. It's hands-on, forging real skills through practice. And it's well-structured, building a deep foundational mastery. It is absolutely worth your time. The top 5 programming languages powering the world right now: Python, JavaScript, Java, C/C++, C#. Each language is a top-tier tool, but for different jobs. The best one depends entirely on what you want to create. The C++ language supports multiple programming types. These are procedural-oriented programming, object-oriented programming, generic programming, and functional programming. Why is C++ so powerful? It combines the raw speed of the C language with modern object-oriented programming features. It is commonly used in game engines, operating systems, compilers, banks, and financial software. How do you learn C++? The steps in learning the English language are: first, you learn the alphabets. Then you form words. Next, you build sentences. And finally, you write a paragraph. Similarly, the steps in learning the C language are: first, you learn the basic building blocks, alphabets, digits, and special symbols. Then, you use them to form constants, variables, and keywords. Next, you write instructions. And finally, you combine them all into a program. How to learn C++. It starts with its fundamental building blocks. First are the alphabets, which include uppercase letters, A, B, all the way to Z, and lowercase letters, A, B, all the way to Z. Next are the digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And finally, there are the special symbols. These include a wide range of characters, such as tilde, exclamation mark, at symbol, hash, percent, caret, ampersand, asterisk, parentheses, underscore, hyphen, plus, equals, vertical bar, curly braces, square brackets, colon, comma, quotation marks, apostrophe, question mark, slash, and the $sign. An important step is understanding constants. Constants are divided into 2 main types: primary constants and secondary constants. Primary constants are the basic building blocks and include integer constants for whole numbers, real constants for decimal numbers, and character constants for single letters or symbols. Secondary constants are more complex data structures built from the primary types. These include array, pointer, structure, union, enum, and others. Here are 4 key reasons for how and why to learn C++. First, it helps you build strong programming fundamentals. Second, it is widely used in game development. Third, it is a preferred language for competitive programming because it is extremely fast. And fourth, it helps you understand how computers work at a low level. Let's talk about variables in C++. Think of a variable as a tiny storage box inside your computer's memory. You give this box a name, decide what type of data it can hold, and then place a value inside it. For example, in an equals 15. Here, int is the data type, is the variable name, and 15 is the value stored inside it. Every journey begins with first step, and in programming, that first step is usually a simple program. Let's write our very first C++ code, the classic hello world. It begins with including the IStream library, which allows us to use input and output. The line using namespace std makes our code simpler. Inside the main function, we use coot to display the text hello world on the screen. Finally, return 0 ends a program successfully. Now compile and run a program. And here's the result. Our program runs successfully and prints hello world on the screen. The message confirms that our code worked as expected, and the return value 0 tells us the program ended without any errors. There are some fundamental concepts of C++. Variables hold information. A variable is a name container, like age or score, that stores a piece of data your program uses. Data types define that information. The data type tells a compiler what kind of information the variable holds. Input and output handle communication. Input, CIN, is how the program receives communication from a user getting data. Output, COOT, is how the program sends communication to the user, showing results. Operators are symbols that perform operations on data. This includes arithmetic, assignment, comparison. Finally, control statements make decisions and create loops. Decisions, if, else, switch, they let your code choose different paths based on conditions. Loops, for, while, they let your code repeat actions without writing the same instructions over and over. In programming, you'll use different data types to handle various kinds of information. First, the int, or integer data type, is used to store whole numbers. These can be positive or negative. Then, for numbers that include a decimal point, you use float and double. Both handle fractions, but with a key difference. A float has a smaller precision. A double has higher precision. Next are the character and string types. The char stores a single letter, digit, or symbol, and it's always written inside single quotes. A string holds text, which is a collection of characters, and it uses double quotes, like. Finally, the bool, or boolean, is simple. It only stores one of two values: true, represented by 1, or false, represented by 0. The bool box is a small container that can only hold a true or false value. The char box is a small container for a single character. The int box is a larger container designed specifically for whole numbers, like 42. The double box is a specialized, high-precision container for decimal numbers, like 3.14. This table outlines common data types in programming, along with their sizes in bytes and bits. The first data type is a nibble. A nibble is half of a byte, which is equivalent to 4 bits. Next is a boolean, often called a bool. It uses 1 byte of memory, or 8 bits, to store a true or false value. Then we have a character, or char. It also uses 1 byte, or 8 bits, to represent a single symbol or letter. An integer, or int, is a larger data type. It typically uses 4 bytes of memory, which is equal to 32 bits. The largest type here is a double. It is used for high-precision decimal numbers and uses 8 bytes or 64 bits of storage. This progression shows how different kinds of data require different amount of space in a computer's memory. Let's look at operators, which are symbols that perform operations on data. First, arithmetic operators: plus, minus, division, multiplication, and modulus for remainders. Next, relational operators like equal to, not equal to, greater than, and less than. They compare values. Then logical operators, and, or, and not, which combine true or false conditions. Finally, assignment operators, from the basic equals to compound ones like plus equals and minus equals. Have you ever wondered how to add numbers using C++? Today, I'll show you how to make a simple addition program step by step. Put hashtag include statements in your .c file, not your .h file. This keeps the libraries private. If you put them in a header, every other file that includes it is forced to load those libraries too. It copies the code for CIN and COOT into your program, so you can do input and output. Inside our program, we often need containers to hold data. We call these variables. For example, with a line in A, B, C, we are creating 3 containers designed to hold integer numbers. Let's talk about the structure of a C++ program. Every single one starts with a function called main. COOT is used for output. It's how we print text to the screen. So, we might write a message asking the user to type a number. To capture the user's response, we use CIN, which is for input, taking what was typed on the keyboard and storing it in a variable like variable A. We do the same thing again. We use COOT to ask for a second number. And then CIN to capture it and save it inside our second variable, B. Next, we perform the calculation. We take the value from container A, add it to the value in container B, and then store the final result of that addition into our third container, C. Finally, we need to show the user the answer. We use COOT again to display a message like the answer is, followed by the value we stored in C. We often add endl at the end, which simply moves the cursor to the next line to keep the output looking clean and neat. To finish the program properly, we use return 0. This line signals to the computer that the program has finished its job successfully without any errors. Now click on Execute and do a compile and run. Put a file name and save it. And then run it. Enter the value of A and B. 32 plus 45 is equal to 77. In C++, the if and else statements help us make decisions in our program. Let's learn how they work with a simple example. Let's break down this simple C++ program together. Its goal is to ask the user for a number and then tell them if it's positive or negative. First, we see the 2 familiar lines at the top. Hashtag include iostream and using namespace std. These are essential. Now, the program's entry point, int main. This is where the program begins its execution. Inside the main function, the program declares a variable called number type integer, or int. This creates a container in the computer's memory, the whole number that the user will type. Next, the program uses COOT to print a message. Enter a number. This appears on the user's screen. The following line, CIN number, then waits for the user to type a number and press enter. Whatever number they type is stored in our number variable. Now we reach the core logic, the if statement. This means if the number is not equal to 0. If this condition is true, the program executes the next line, printing the number is positive. If the condition is false, meaning the number is equal to 0, the program jumps to the else block and prints, the number is negative. And finally, the program ends with return 0, signaling a successful execution. And then compile and run. I enter a number 5, and this number is positive. Now let's look at another example of if and else in C++. This will help you understand how conditions control the flow of a program. This part is very important. Hashtag include iostream and using namespace std. Every C++ program starts running from the main function. Here, number is an integer variable where the user's number will be stored. Then we ask the user to enter number. Coop prints a message on the screen asking for a number. CIN takes input from a user and stores it inside the variable number. Now comes the most important part, checking if the number is even or odd. Here, the operator percent is called the modulus operator. It gives us the remainder when one number is divided by another. If number percent 2 equals 0, that means the number is perfectly divisible by 2, so it's even. Otherwise, it goes to the else part. And the program will say the number is odd. Then we write return 0, and then compile and run. Enter a file name and save it. I enter number 4, so number is even. If we enter number 5, so number is odd. The for loop in C++ is used to repeat a block of code multiple times. Let's see how it works with an easy example. The first line is hashtag include iostream. Next, we have using namespace std. Now, inside the main function, we see a for loop. The loop is written like this. For in equals 1, I equals 5, I++. This statement has 3 parts. Initialization. In I equals 1. This means our loop starts with a value of I equal to 1. Condition. I equals 5. The loop will keep running as long as I is less than or equal to 5. Update. I++ after every loop, the value of I increases by 1. Inside the loop, we have coot I end L. This prints the value of I followed by a new line. At the end, the program returns 0, which means it has successfully finished. Now compile and run this program. So, what happens when the program runs? First, I equals 1 and it prints 1. Next, I equals 2 and it prints 2. Then I equals 3, it prints 3. After that, I equals 4, it prints 4. Finally, I equals 5, it prints 5. When I become 6, the condition I equals 5 is no longer true, so the loop stops. Let's explore another example of the for loop in C++. In this program, we are learning how to print the multiplication table of a number in C++. The first line is hashtag include iostream. Next, using namespace std. Now let's look inside the main function. We declare an integer variable named number. This variable will store the number entered by the user. The line coot enter number displays a message on the screen asking the user to type a number. Then cin number takes input from the user and stores it inside the variable number. After that, we display a message. Coot, multiplication table of number, :n. This tells the user that the table is about to be printed. Now comes the important part, the for loop. Here, I equals 1 means the loop starts with I equal to 1. I less than or equal to 10 means the loop will continue until I becomes 10. I++ increases the value of I by 1 after every step. This line prints the multiplication in the format. For example, 5 times 1 is equal to 5. 5 times 2 is equal to 10. 5 times 3 is equal to 15, and so on until 5 times 10 is equal to 50. The loop repeats this process for every value of I from 1 to 10. Finally, the program ends with return 0, which means it is executed successfully. Now we compile and run a program. Here, you used I equals 10 instead of I less than or equal to 10. I equals 10 is an assignment, not a condition. This sets I equal to 10 every time the loop checks a condition. Since in C++, any non-zero value is treated as true, the loop never ends, and it keeps printing only Number x10 equals result. Again and again. The do-while loop in C++ runs the code at least once before checking the condition. Let's see how it works with an example. Let's break down this simple C++ program that demonstrates a do-while loop. We start with a preprocessor directive, #include iostream. Next, we are using namespace std. Now we enter the main function. Every C++ program must have a main function. It's a designated starting point where execution begins. Inside the main function's curly braces, we first declare an integer variable named number. This variable will be used to store the number that the user enters. The key part of this program is the do-while loop. Let's see how it works. The code block following the do keyword will always execute at least once before the condition is even checked. Inside this loop, we use coot to print a message. Enter a number, 0 to stop. Then, we use cin to take the user's input and store it in our number variable. The loop's condition is found after the while keyword. While number is not equal to 0, this means that after first execution, the program will check the value of number. The program then moves to the next line, which prints you exited the loop, confirming the program has finished its task. Now compile and run a program. If the user entered any number other than 0, the condition is true, and the loop will run again, prompting for another number. Once 0 is entered, the condition number equals 0 becomes false, and the loop terminates. Let's see another example of the do-while loop in C++. This will make the concept even clearer and easier to understand. Let's walk through the C++ program, which demonstrates a practical use of a do-while loop for a simple password check. The program begins by including the necessary library, the line #include iostream. Next, we are using namespace std. Now, we enter the main function. This is the entry point of every C++ program. Execution starts here. Inside the main function, we declare a variable, the line string password. Create a variable named password that is designed to hold text or a sequence of characters. The core of this program is the do-while loop. This type of loop is perfect for situations where you need to run a block of code at least once, and then repeat it based on a condition. In this case, we need to ask for a password at least one time. Inside the loop, the program uses coot to print the prompt. Enter password. Then, it uses cin to take whatever the user types and store it in our password variable. The loop's condition is while password is not equal to 1234. This means that after the user enters a password, the program checks it. If the input is anything other than the string 1234, the condition is true, and the loop will run again, reprompting the user. This creates a cycle that continues indefinitely until the correct password, 1234, is entered. Finally, return 0 signals that the program has ended successfully. Now compile and run a program. I entered a correct password 1234 and pressed enter. Immediately, the program recognized that this input matches the correct password stored in the code. Because the condition of the do-while loop is now false, the password is no longer not equal to 1234. The loop breaks. The program then moves to the next instruction, which prints the message, access granted, confirming that the authentication was successful. In C++, strings are used to work with words and text instead of just numbers. Let's see how we can use strings with a simple example. The code starts with the necessary lines. Include iostream and using namespace std to handle input and output. Inside the main function, an integer variable named day is declared. The program then prompts the user to enter a number between 1 and 7 using coot and waits to read their input using cyan. The core logic is the switch statement. It takes the value of the day variable and compares it to different case labels. Each case represents a possible number the user might enter. If the user enters 1, the program will jump to case 1, print Monday, and then hit the break statement, which exits the switch block entirely. If the user enters a number 2, the program will output Tuesday and then break. For 3, it prints Wednesday. For 4, it's Thursday. For 5, it's Friday. Case 6 handles the number 6 and prints Saturday. Finally, case 7 corresponds to the number 7 and will print Sunday. But what if the user doesn't follow instructions? What if they enter a number like 8 or 0 or even a negative number? This is where the default case comes in. It acts as a catch-all. If the value of the day variable doesn't match any of the specified cases from 1 to 7, the program will automatically jump to the default case. Here, it prints the message invalid day number, which tells the user that their input was not within the expected range. Now compile and run a program. I entered the number 5, and the switch statement correctly executed case 5, printing Friday to the console. Let's try another example of strings in C++. Here it starts by including the necessary library hashtag, include iostream, and using namespace std. Inside the main function, it declares a character variable named light. The program then prompts a user to enter a single letter, R for red, G for green, or Y for yellow. The switch statement then checks the value of the light variable. If the user enters the uppercase R, the program will print stop. If they enter G, it prints go. And if they enter Y, it prints wait. The default case is crucial here. It acts as a safety net. If the user enters any other character that isn't R, G, or Y, like a lowercase letter, a number, or a symbol, the program will catch in the default case and print invalid light, ensuring the program handles unexpected input gracefully. Finally, return 0 ends the program successfully. Now compile and run a program. The program is giving an invalid light message because of a case sensitivity issue in the code. Look at the input. I entered a lowercase y. However, in the switch statement, the programmer only checked for uppercase letters, case R, case G, and case Y. How can I create a basic calculator? Using the C++ programming language? First, we include the header file iostream and write using namespace std. Inside the main function, we declare a character variable called op to store the operator, and two double variables, number 1 and number 2, to store numbers. The program first asks the user to enter the first number and stores it in number 1. Next, it asks the user to enter an operator, like plus, minus, multiply, or divide, and stores an op. Then it asks for the second number and stores it in number 2. After taking the input, we use a switch statement. If the operator is plus, it adds the two numbers and displays a result. If the operator is minus, it subtracts the second number from the first. If the operator is multiplication, it multiplies both numbers. For division, the program first checks if the second number is not equal to 0. If it is not 0, it divides the first number by the second and shows a result. But if the second number is 0, the program prints an error message saying, division by 0 is not allowed. Finally, if the user, E, enters any operator other than plus, minus, multiply, or divide, the default case is executed and the program prints invalid operator. At the end of the program, we write return 0. This tells the operating system that the program finished successfully. Now compile and run a program. The program first asks to enter the first number. Here we enter 5. Next, it asks for an operator. We enter the minus sign. Then it asks for the second number. We enter 1. The program processes this input and shows a result. It displays result equals 4. So, our calculator is working correctly and giving the right result. Thank you for watching my video. Don't forget to like, subscribe, and share this video.